This is the physics chapter 7 final exam review. You'll need to get out your sheet that contains all the questions. We're just going to do these 5 questions from chapter 7. And I printed them out a little bigger so hopefully you could see them on the video. So with chapter 7, some of the equations I went ahead and put up here at the top of my board. Centripetal force, mv squared over r. Centripetal acceleration, v squared over r. The gravity, force of gravity equation, g times m1 times m2 over r squared. Period for circular motion, circumference over velocity, and then frequency is just 1 over the period. So the first one is, what is the radius of curvature of a 2002 Mercury Villager? That's a minivan that I used to drive when I originally wrote this question back in 2008. Taking a circular curve at 50 meters per second, and our coefficient of friction is 0.3. Okay, so what is keeping the minivan going in a circle, all right, as it travels around that circle? Is the force is friction. So friction is what is equal to F sub C. So what is friction? Well, friction is mu sub K times the normal force. Well, what's the normal force? The normal force is equal to the weight, which is just equal to mass times gravity. All right, so mu, and it is sub K, but I'm going to leave that off, times mass times gravity, that's the normal force, is equal to the centripetal force, which is mv squared over r. Now, masses will cancel out. We know in this problem that mu is 0.3. We are trying to solve for radius. All right, so doing the algebra, let's bring the radius out here and put mu times g underneath. You'd have v squared over mu times g. All right, the velocity is 50. You can tell I wrote this problem. Nice, easy velocity. Don't forget to square it. Over 0.3. And since we're in meters, it's going to be 9.8. All right, you put that in your calculator and you get 850 meters. That's about half a mile. So that van is going pretty fast, and the friction necessary, you're going to have a pretty big, with a coefficient of friction of only 0.3, you're going to have a really big circle. So if that was higher, you could have, if let's say the coefficient of friction was 1, then you'd be able to take that radius down by a third. Okay, that's number 1. Number 2, bringing it into view, it says a 1,000 kilogram hunk of space junk orbits the Earth. It's a speed of 12,000 meters a second. What's the junk's radius of orbit? What's its period? What's its frequency? Okay, so we can get kind of 3 problems in one here. We know that the centripetal force that is keeping the space junk in orbit is gravity. So F sub C is equal to F sub G. All right, and that would be M, so the mass of the junk times V squared over R is equal to G. Now, it's orbiting the Earth, so the mass of the junk times the mass of the Earth over R squared. All right, the mass of the junk cancels out. 1 of the radius cancels out. So we'd have V squared is equal to G times the mass of the Earth over R. So the radius is going to be g times the mass of the Earth over v squared. So you don't have to memorize 6.67 times 10 to the minus 11. That's g, but you might remember it. The mass of the Earth is 5.98 times 10 to the 24th. And then it says our velocity was 12,000 meters a second, and we have to square that. Okay, so if you put that in your calculator and you don't accidentally mess it up, you'll get a radius of 2.77 times 10 to the 6th meters. Now we can use that to get the period. So we know that period is going to be 2 pi times that radius, 2.77 times 10 to the 6th, over the velocity, which is 12,000. So that will give us a period of 1450.4. The unit is going to be seconds. And then to get frequency, it's just 1 over the period, 1 over 1450.4 seconds. All right, and that's going to be 6.9 times 10 to the minus 40. Remember the unit for frequency, it's what? Hertz. All right, so that's a good problem. It kind of gets a 3-in-1 situation going there. All right, so pause if you need. Number 3. Says Ariel, a moon of, they pronounce it Uranus now for obvious reasons. So Ariel, a moon of Uranus, has an orbital radius of 1.91 times 10 to the 8th meters. What is Ariel's orbital period? All right, so period, we need, they gave us radius, we don't have velocity. So we need to get velocity. We can get that by going through the process of F sub c is equal to F sub g. So that's going to be the mass of Ariel times the velocity squared over r is equal to g times the mass of Ariel times the mass of Uranus over r squared. So the mass of Ariel cancels, 1 of the radius cancels, and you'd have v is equal to the square root of g times the mass of Uranus, had said, over r. So that's the square root of 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared, but I don't want to write all that. The mass of Uranus, 8.68 times 10 to the 25th. About 10 times that of Earth, right? And it's made of gases. It's not solid, so impressive. That's 10 times Earth, and it's all gas. Over r, which is 1.91 times 10 to the 8th. Meters. So the velocity, if you get it right in your calculator, is 5505.6 meters per second. Don't circle that though, because we're getting the period. So the period, all right, how long does it take Ariel to make one loop around Uranus? Well, it's 2 pi radius 1.91 times 10 to the 8th over the velocity we just figured out, 5505.6 meters per second. and that is 2.18 times 10 to the 5th seconds. And if you're interested, that's about a little over 60 hours. But go ahead and give it to me in seconds. All right, so that's it for number 3. Let's try number 4. Number 4 says an object moving in a circle of diameter 15 centimeters has an acceleration of 5.5 meters per second squared. Will move with what velocity? All right, so we're just going to use this centripetal acceleration formula. We need to solve for velocity, so that'd be the square root of a sub c times r. They gave us the diameter and they gave us in centimeters, so we have to be careful. A sub c is 5.5. Then the radius is 15 centimeters. That'd be 7.5 centimeters for the diameter is 15, 7.5 for the radius. So divide that by 100 and you'd have 0.075 meters. So I think one of the reasons I put this in here was just to make sure you didn't mess up on and leave it in centimeters. And so that is 0.64 meters per second. And I think I can fit number 5 on the board here. What's the mass of an object moving in a circle if 15 newtons of centripetal force is applied to the object with a radius of 0.31 meters? The object is at a constant velocity of 8 meters per second. Well, this is just a plug into the centripetal force formula. F sub c is equal to mv squared over r. Okay, so if we want to know the mass, that's going to be F sub c times r over v squared. So F sub c in this problem is 15 newtons. The radius is 0.31 meters. Don't even have to do a conversion there. And the velocity is 8 meters per second. Don't forget to square that. And your calculator will tell you 0.073. And since we're in meters, it's going to be kilograms and not slugs. That does it. That's a good review of Chapter 7. Just make sure that you rework the practice problems and extra practice problems, or at least work some of them. And I will talk to you in the Chapter 8 review video.